Greetings. The purpose of this presentation is to help explain what leads to ladder instability and ladder falls. In this example, we will use a standard 16-inch wide ladder that is 24 feet in length. To understand why ladders tip over, it is important to understand the physics behind the fall. To do this, we need to know where the center of gravity is. The center of gravity is the average location of weight of an object. Since a 24-foot ladder is symmetrical, the center of gravity is in the center of the ladder. When the center of gravity moves past the outside leg of the ladder, it is in a position to fall. Gravity does the rest. An important point to note is the ladder cannot tip without the base of the ladder also moving. For a 24-foot ladder, this is approximately an inch of movement. As we mount and climb a ladder, the center of gravity shifts. Since a person outweighs the ladder by a great deal, the center of gravity shifts with each step. Since we climb a ladder with 1 foot at a time, that means all of our weight is shifted to one side of the ladder. As we walk up the ladder, the center of gravity shifts with our weight from side to side. As we approach the top of the ladder, the shifting center of gravity is creating a situation that could be quite dangerous. With the weight near the top and the center of gravity to one side, it's quite easy for that side of the ladder to sink into the ground or for the ladder to simply shift to that side. As the ladder sinks into the ground a slight amount, it's very easy for the top of the ladder to pass the tipping point. For a 24-foot ladder, a small 1/4 inch of movement on the base will result in more than 4 inches of movement at the top of the ladder. This is probably enough to cause a ladder accident. Thor stand, a ladder leveler and stabilizer, significantly improves ladder stability. Much like an orchard ladder, Thor stand creates a broader base and provides a significant improvement in ladder stability. The furthest out a person can stand on this example is the edge of the ladder. This also means that the furthest the center of gravity can move is the edge of the ladder. With a base 8 inches wider than the ladder, the center of gravity is nestled comfortably within Thor stand's broader base. The other important advantage of a wider base is that the amount the top of the ladder moves is directly related to the width of the base of the ladder. By doubling the width of the ladder base with Thor stand, it takes twice as much movement at the base of a 16-inch ladder to cause the same movement at the top of the ladder. A 1/4 inch movement moved a 24-foot ladder 4 inches before. With the Thor stand, it will only move 2 inches. To get a ladder to tip with Thor stand, the center of gravity must move past the outside leg 8 inches farther than before. A 24-foot ladder without Thor stand required only 4 inches of movement before it tipped. With Thor stand, it requires an additional 8 inches of movement or 12 inches of movement at the top before a ladder fall. A 300% improvement in safety margin. The top of the ladder cannot move without movement on the base of the ladder. In most cases, the reason for the ladder fall is that the base of the ladder sunk in the ground on one side, or the climber reached out past the edge of the ladder, moving the center of gravity beyond the tipping point. A ladder using a Thor stand requires 5 times more movement at the base to tip the ladder. Thor stand improves ladder safety by as much as 500%.